अब आसन ग्रहणको क्रमबाट सायद प्रोग्राम सुरु गर्नु पर्ला। आसन ग्रहणको लागि नेपाल विद्युत प्राधिकरणका कार्यकारी निर्देशक श्री कुलमान घिसिङज्यूलाई यस सेसनको सेसन चेयर गरिदिन हुन हार्दिक अनुरोध गर्दछु। त्यसै गरेर प्रोफेसर डाक्टर हरिप्रसाद नेउपाने काठमाडौँ विश्वविद्यालयबाट प्रेजेन्टरको रूपमा आसन ग्रहण गरिदिनु हुन हार्दिक अनुरोध गर्दछु। आसन ग्रहणकै क्रममा मिस्टर Isturo Gonzalez, please take a seat on the dais. I'd like to request Isturo Gonzalez, Techno Hydro Energy India Private Limited. Please take a dais. Likewise, I would also like to invite Mr. Denjil Swami, Manager Business Development, AK Energy Service Limited, India. Please take a seat in a dais. Likewise, I would like to request Mr. Jayaraman Punidham, Head of Business, Vice President, Adani Group, India. Please take a gracious seat on a dais. And I would also like to request Mr. Gyanendra Lal Pradhan, Advisor of IPAN, please take a seat on a dais. Bibji, खोइ त्यो स्वामी आउनु भएन नभए दिनु म माइकै दिनु नि त म यतैबाट बोल्छु माइकै दिनु नि म उतैबाट Dhanyavad. Altogether, we have got a fantastic presentation today. So basically, it's more about navigating the future of renewable energy. So we have got 2 presentations from Nepal and 3 presentations from India and abroad. We have like 4 technical presentation. One is like speech presentation and 1 video presentation. And sum up will be done by session chair, Mr. Kulman Gising at the end. So everyone, I mean, all the presenter will get like 10% to present their presentation and 5 minutes for question answer. So altogether that comes around 60 minutes. At the end, Mr. Gising will get like 15 minutes and question answer for 5 minutes. So altogether I'll try to wrap up before the time. So I would like to begin with Professor Dr. Hariprasad Neupane to present his presentation. So he have like more than 30 years of experience in various development agency, Kathmandu University as a professor, and he also worked as a resource person for many international DFIs as a hydropower expert. So I would like to request present on the power of digital, harnessing the power of data, digital transformation in hydropower plant in enhanced performance and predictive maintenance, latest technology in energy sector and its significance. Please. Yeah, you can also. Please.
Thank you very much for a very nice introduction. My name is Hariprasad Neupane. I am professor at Department of Mechanical Engineering, Kathmandu University. First of all, I would like to welcome you all in my presentation. My topic for today's presentation is digital transformation in hydropower plant. So here basically my presentation will focus why we need this digital transformation in hydropower plant. So this is quite a new and innovative idea, especially in the hydropower field. So I try my best within the given time frame to justify the topic, and hopefully I will get very good questions at the end of the presentation. Then I will have more time to explain you. Thank you. Then this is the outline of my presentations. I try to cover the scope of the hydropower in our region, especially South Asia, including China. Then sediment transport in our part of the world, which is one of the enemy we call in hydropower field. Then some of the problems related to sediment. Then previous study, what we are doing at Kathmandu University Turbine Testing Lab. Then maintenance practice in Nepal. Then why digital hydro? That things I try to explain here. Then digital transformation. If we implemented digital transformation in hydropower field, then what we'll get out of it? In this way, I try to wrap up my presentation. So let me tell you something about the status of the hydropower in our part of the world. So still we harness only 15% of the hydropower, especially if we look the data of the South Asia. Then why it is? Is it because of the geopolitical reason or because of the something else, financial reason? But as a technical person, I would say this is because of some of the technical issues, that is sedimentation. Then if you look the scenario in the China, for example, there also only less than 60% hydropower so far China harness. Forget about Nepal, only 7%, less than 7% of total technical feasible hydropower potential we harness till date. This is because of the erosion and sedimentation issues, we are unable to harness the hydropower what we expect to harness by this time. So then let's look, this is the map of the sediment concentration in different parts of the world. I would like to share one data. In the world, there are about 20 billion tons of the suspended materials that is carrying by the different rivers and streams throughout the world. Out of that 20 billions, about 70% of it, 14 billions, that is from Indian subcontinental. This means that we need to play with this sediment. This is the huge. Then what is huge? Then I would give one example. This is the different rivers in Nepal. If you look one of the river, that is the Narayani river, where we are about 0.2 million tons of the sediment we can collect in 1 year. Meaning that if you collect that sediment in Kathmandu Valley, in 1 year you can see the height of the Kathmandu Valley will increase by 1 meter. Then you can imagine how big is the sediment that is flowing in our Nepalese river. So this gives the problems. Then what kind of the problems? This is the problems. I think we are already familiar. We are the hydro family here. Then everybody familiar about the life of the turbine. Turbine is the heart of the like human body. So in turbine, because of the high suspended sediment that is coming and hitting the turbine materials, then this will not only reduce the life of the turbine, but also increase the repair and maintenance. Then ultimately it will use financial losses. Then what is that losses? How much that matter for us? That things also I'll share with some of my previous study later on. And this is, of course, this is mostly in our part of the world where our geology is very fragile, very young, and the intense rainfall and tropical mountains. But this is also, this type of the problems is available in South American region also. But where they don't have any type of the sediment erosion problems, if we use the same type of the turbine in our part of the world, then we can expect the repair maintenance and some of the problems in our turbine even after one monsoon period of the time. Then we are losing a lot of efficiency. Forget about what type of the turbine we are using. All types of the turbines, wherever we use in our part of the world, we supposed to handle these sediment erosion problems. This sediment erosion is the natural phenomena that neither we completely control, neither we completely avoid it. However, we can manage it. This is the engineer jobs in our part of the world so that we can develop our own turbine, then we can develop our own strategy in order to do the repair and maintenance Why? Because we have already developed about 3,000 megawatt hydropower project. So many turbines that has been already installed. And there are so many projects in the pipeline where we can introduce the new and innovative idea, not only in terms of controlling the sediment, but also to design the appropriate type of the turbine so that that will handle the sediment erosion problem very smoothly, so that we can expect the life of the turbine will be much, much more longer. Then there are some of the financial aspects. I will say one of my previous study, how much it matters for us. If, with the help of sediment erosion, if we increase the thickness of the, let's say, splitter of the Pelton bucket by 1 millimeter, then we are going to lose 1% efficiency. In reality, we can lose the efficiency up to 8% that we observe in some of the hydropower projects in Nepal. If you lose efficiency up to 8%, then after one monsoon, then life of the hydropower is about 100 years, then how much efficiency you are losing? Then how much money it matters for us? I have calculated by taking the example of about 300 megawatt hydropower project with the today's energy price. If we lose 1% efficiency out of this 309 megawatt hydropower project, then we are losing about $1 million in a year. Then think about that. Our government slogan is 15,000 megawatt in 15 years. Then if you have a 15,000 megawatt, if you lose the efficiency about 8% after one monsoon, then how much money you are losing in order to do the repair and maintenance? Then this is the challenge. This challenge we need to tackle. Then only we can think about the hydropower and prosperous Nepal and future of the hydropower. So this is the things I would like to tell over here. Then another thing is why digitalization? Digitalization is or digital transformation in hydropower. Why it is? There are two aspects. One is global aspect, another one is the local aspect. In the global perspective, nowadays, a lot of integration in the hydropower grid. For example, wind, solar, then other sources of the energy that we need to tackle from the hydropower in the other part of the world, especially for western part of the world. Then they need a lot of flexibility. That kind of the flexibility they can expect from the hydropower. If you need the flexibility, then why not it is from hydropower? That's what digital transformation is needed for them as well. Then what is this for us? In our part of the world, this sedimentation issue is the global, not only the global, but also the local major problems. In order to tackle this, we need this digital transformation. By introducing this digital transformation in hydropower field, then only we can tackle the issue of sediment erosion by some extent. So, then what is the different types of the maintenance we are doing in our country? Basically, we are doing only two types of maintenance. One is that is run to fail type of the run to break type of the maintenance. Another one is preventive maintenance. That is the kind of the routine maintenance. So once the things fail, then only we are forced to do the maintenance. Unless and until turbine completely stop or to technically death, we are running the turbine. That is not good at all. This is the kind of the maintenance we are following. Then and another one is routine maintenance. Some manufacturer provide you some sheet. Based upon that, you are going to change the bearing temperature. You are going to do some repair and maintenance of the turbine. But there are some other type of the maintenance exist in other part of the world. That's what digital transformation is needed. So from that, I will relate the maintenance strategy. In order to propose the new maintenance strategy, in order to enhance the performance of the turbine, then digital transformation comes into the picture. Then what is the maintenance practice? Thanks Managing Director of the NEA, who is here, who supported us by giving some seed funding in order to do this condition monitoring project in Nepal. And then we got the funding from Nepal Electricity Authority. Then we did a lot of work, especially for the condition monitoring. From that project, we gathered the information that there are so many projects under the NEA where they are doing what kind of the maintenance. From that, I came to conclusion that there are only two types of the maintenance exist in different parts of the hydropower project in Nepal. But then we are not practicing any type of the condition-based monitoring system. If that is possible in human health or in our in medical science, then why not in hydropower field? That's what we are doing research on this line. Then here, this concept of the digital transformation comes from the maintenance point of view. Of course, there are so many aspects of digital transformation of the hydropower field, but I try to explain that from the this preventive maintenance point of view. So here, I will take the example of condition-based monitoring. What is that? What is the condition-based monitoring? In order to discuss that, I will take some example. For example, if you have a turbine without running any let's say 0 hour of operation. In 0 hour of operation, you can take the different reference data set. For example, you can take the pressure, temperature, flow, then RPM, efficiency, displacement, so many parameters. First, you need to measure. Then once you operate the turbine in, let's say, X hour of operation, then you will have different parameters. Of course, this parameter definitely not same. There are some deviation. Then that deviation you can monitor at the X hour of operation, then that shouldn't be same as the reference data set. Then what is the cause of the deviation? Whether that deviation is as per the expected limit or not. If not, then what is the cause of that deviation? That might be because of the possible causes of the deviation. That might be leakage, that might be friction, that might be erosion, that might be cavitation, or that might be something else. If you go to the hospital and check up your blood pressure, then doctor say what is the health of your heart. Then by knowing this parameter, then deviation, X hour of operation, if you know all these parameters, then you know the health of your turbine. That is called the preventive maintenance we are trying to apply from the digital transformation in hydropower field. Then this is overall digital transformation process that involves the physical parameters. There are so many sensors, data acquisition system, signal processing, monitoring program, data storage, data analysis, and fault predictions. From there, we try to find out the root causes of the problems. Then before a system fails, before some components fail, before that critical component identified that is potential to fail, then before that, if you apply the maintenance technique, then that will cost effective, as well as, thank you, as well as that is time saved. So this will, reduce the cost of the maintenance as well as enhance the performance of the system. So these are some of the works we are doing at the moment at Turbine Testing Lab. We are intentionally we are introducing the different fault signal in the turbines and their geometry by knowing the experience from the different hydropower project, by observing the different phenomena in the hydropower project because of the sediment erosion, because of the something else. So then we try to relate that with the field data. Then we generate the lot of data set. Then from this data set, we also apply this concept in one of the hydropower project that is located very near to the Kathmandu University, Khopasi hydropower project, which is 2.4 megawatt. There we try to implement this concept, then show the demonstration unit how the digital transformation of the hydropower takes place. So this is the work I would like to share over here. Then this is the sum of the data. By knowing this deviation of the data, then you will get the SMS or email signal what is going on in your powerhouse or in your turbine, for example. So this is the kind of the things we are checking from by sitting Kathmandu, checking the hydropower status of the Jumla. These are the things we want to change in our hydropower field. This is called the digital transformation. And another beauty of digital transformation is, so this is the another example of Pelton turbine. Then finally, I would like to conclude like digital transformation not only increase the efficiency and give the optimized performance of the turbine, but it is also the cost reduction, reliability and resilience, and these are some of the examples. And the future is the digital transformation of the hydropower. Don't think always conventional way. Let's move further. Let's work together so that we can achieve the 15,000 megawatt in 15 years. Otherwise, we are talking always. We are talking always 83,000, always 83,000. Still, we are suffering in the load shedding during the dry season. Thank you very much. Thank you very much for your time and attention.
Thank you. Good presenter makes life much easier for moderator. So we will ask only 2 questions. We'll take 2 questions, and each and every one, we'll give an opportunity to ask two questions, each presenter. And best question, we'll get award at the end. So be aware. So anyone? So can you give mic, please?
Thank you.
Please introduce yourself.
My
नेपालीमा गर्नुभएनुहुन्छ?
My name is Yuvraj Shrestha. I'm involving in the small hydropower project. So my question here is a very good presentation and sedimentation. So there may be some solution to reduce the sediment. So this presentation doesn't tell us about this remedies of the sedimentation. Another thing is digitization. Okay, it's a very good thing for the monitoring. And so some software. Tell us about this software. Thank you.
Next one and only now. Next question. Anyone?
Hello. Namaste. I'm Dr. Suman Pradhan. Actually, it's a good presentation from Harish sir. The one thing I just want to add is my curiosity and as well as interest. Can we add digital twin on this one with all your data collected for past 25 years or whatsoever, so we can have our powerhouse in our room or in our lab or in our office? Have you ever thought about those things rather than just like condition monitoring? Yes, it's both related together, but digital twin is something way forward. What do you think?
Yeah.
How much time I'll take? Thank you for very nice questions, both questions. Yes, I fully agree with the first questions. Like there are so many ways to control the sediment. I would say I also did a lot of research on this line. I would say there are three approach, C, C, D approach. One C is by any means if you control the sediment in order to flow towards the turbine. That is one. So that there are so many hydrocyclones, there are so many sediment setting design, there are so many things already done. That is civil aspect. Another C is for the existing hydropower project, you need to apply the different types of the coating so that you can prolong the life of the turbine for the already installed hydropower project. Then another one is D, that is the design, new and innovative design of the turbine. Why we always rely on the German design, where they design the turbine without considering the sediment erosion? Why not we design our own turbine for our own condition, where we can consider the sediment erosion as one of the design parameters? That's what, there are so many ways to tackle the problems. This is multi-dimensional approach. Then once we work in the team from the multi-dimensional approach, then only we can minimize the effect of the sediment erosion, but don't think that it will be completely solved. But we can extend the life of the turbine. That is first. And second one, of course, our journey towards the digital twins, no doubt about it. But in order to reach there, first step is condition monitoring. That is the starting point. And final goal is digital transformation, digitalization. And in order to do that, of course, we can do in the digital twins, where we can work together, no doubt about it. Probably you will be the one of the manufacturers in Nepal who can build that digital twins for us. Then we can do the experiment in the lab. Thank you. I am looking forward to work with you. Thank you all.
Thank you, Doctor. Now we have a excellent presenter again from India. So he's from he's Techno Hydro Energy India. So they provide water to wire service for electromechanical item. He is a head of engineering and control. He is doing this. I mean, he is in this company since last 15 years. Please welcome Mr. Estuardo Gonzalez for his next presentation. So I'll remind you in 9 minutes. Please.
Okay. Namaste, everyone. It's a pleasure to be here. So, on the idea about digital transformation and what can be done with the automatization of the systems and the grouping of all the sensor information, we want to show a little bit of how we're tackling that sort of new designs and new operations for hydroelectric power plants. So we are a company based on Latin America, on Guatemala. We have an engineering office on Italy. All our manufacturing is done on Latin America. And we've covered services for Central America, Mexico, a little South America, and we're just getting into the South Asian market quite recently. We design, supply, manufacture Pelton, Kaplan, and Francis runners from 50 kilowatt to 20 mega. I'm going to speed a little bit because of our time range. A little bit of where we have some presence. So we're trying to take the SCADA and automation to a new level to approach current trends. And so in the old ways, this is kind of what was represented, or it still is, which are operation screens which should be aiding the operation of the power plant. However, within this kind of designs, how can you tell what are the conditions of the system? Is it running okay? They usually just to mimic the electrical or the PNID schematics. There's minimal or very poorly depicted numerical data, and there's no obvious correlation between what is being shown and what it represents on the operation of the plant. So there's a lot of pretty pictures, but from this kind of example, there's only 10% of information in there. Actually, 10% of data, not information, just raw data that you have to interpret, and you have to have certain knowledge to take the correct decisions, to make the right decisions. So what are the current designs? The current designs focus on something called situational awareness, which is trying to figure out what the information is from the data that you can collect on the system. Give enough information in such a way that it is easy to know what's going on. You don't have to be an expert. So I really like this kind of example. So the best example I've seen is in a medical exam, you get a sheet of paper with a lot of numbers that you have to be an expert to figure out if, I don't know, blood cholesterol is all right and whatever other parameters. However, when you present that information in the way like in the picture below, then it's very easy to see if the data is between the correct parameters, if it's a little bit out of range, or if it's in a warning range or in a tripping range. And that makes information easier to take better decisions at the right time, and not when it's something catastrophic might have already happened. So we engineer our solutions on an electrical SCADA system, which gives us a little extra advantages, like having electrical protocol communications native to the system. And the benefit of having electrical parameters is that they automatically manage something called the time stamping. So it's not important just to know what's going on. Sometimes it's really, really critical to know when that happened. So you can figure out if there's an avalanche of events, which was the triggering, what was the first thing that happened. And electrical protocols give you that advantage over traditional automation protocols. In this kind of systems, historical data is something that comes by default. There's no extra manipulations, extra software, extra engineering that needs to be done to have the so important historical data, so you can run analysis and see what the tendencies of the operation has been evolving through time. And so how do we approach this? How do we make this tangible? So for navigation, we try to keep it simple, but with enough information to be able to diagnose and operate the power plant. So we go from a very general, screen, but very quickly we show how's the water reservoir system, if it's online, if it's not online, if it's generating how much. So not a lot, but enough just to get a very, very quick overview of the whole system. Once you start digging in, then you start getting more and more information that makes sense to the operator. So this is like a general typical screen of our system, which would have a little more information, but there's a sub-menu to go to every specific subsystems that should be available to the operator, like the hydraulic system, the lubrication system, the ADR, the digital excitation system, the speed governor, and so on and so on. But if you try to crowd everything, then information gets lost. It's too much to be processed correctly. And you should not be need to dig down so much. We have a kind of philosophy that 3 to 4 clicks and you should get whatever information you're looking for. And that's what we try to decide with this kind of applications. On a situational awareness, what that means is try to give extra information or present the information in a way that's going to give context to the numbers that you're seeing. So, for example, if you're seeing the temperatures of a power plant, then does this have a? Yeah. All right. So we show what are the alarm values, what is the tripping value, not just the raw number. That gives context to know what's going on. With one click, you can access the historical data, the trend for it, so you can quickly see if it's under normal behavior or if it's getting out of range, if there's an unbalance on the historical behavior of the system. And we give some statistical analysis as well, so you can see the value, but we show what's the average value and the highest value of the last hour and on the last day. So all that information, the idea is to complement the operator, the operation of the plant, the day-to-day, in order to make better decisions without the need of having years and years of expertise to figure this out. Design should also have or work under a hierarchical view approach. So this is an example for a large hydroelectric system. It has 3-4 power plants distributed under several rivers. So you start digging in on the navigation until you get to the units. So you have a quick access to the units, and on the horizontal top line, there's the navigation for each subsystem, like I was commenting before. And for figuring out alarms, we also do this same hierarchical approach. If there's something going on, then a general icon for the whole plant is going to change color. And once you start seeing the subsystems, then the subsystems that's currently alarmed is going to change colors. So you don't have to try and guess and navigate the whole system to see these alarm ranges. And once you go there, then it's very easily to see. In this case, it's communications. One equipment is out of communications. That's trying to make life easier to the day-to-day operations. We also have an alarm view, which we try to catalog under priorities. Not a lot, because it should be simple. So the first priority is going to be trippings, alarms that are going to make the machine stop. Then we have communication alarms. Then we have general alarms, and if it's just a normal operation, then it doesn't have any kind of priority. But this is also organized on a sequence of events. So according to the time that we get the alarm.
You have 1 minute.
Well, okay. So we try to keep everything simple, but this is on the operation level. So I'm going to skip a little through. And we're going, what's coming after this operation level. So let me just power through. We're trying to we're providing this information to the decision makers, to analysts that are outside the plant. And these people should not have a view of the same SCADA system. The SCADA system is for operation in the plant. This is information that should be available to those that need it at any time, at any moment, without waiting for reports, without waiting for transcribing. So we extract the important information, we push it to a cloud system, which allows us to develop top-level dashboarding to see what's going on. So this is for the stakeholders, this is for the analysts, this is for the management analysts to take informed decisions following the digital transformation of the systems. So this is not the SCADA, this is not going to have the granular alarms, but it's going to show you the tendencies on temperatures, on power generation, on efficiency, on statistics on how long have the machines been running, how much time has it been running? Is it time for a preventive maintenance? Is it over its lifetime hours of operation and so on? So this is a very simple, very attractive view, which can be seen from any phone, any tablet, any device outside the power plant, with its cybersecurity issues concerned, like user password and so on and so on. But it's information available for top-level decisions. For condition monitoring, this is an example of a power transformer. So we can add information that is usually not on the power plant, like climate, weather information, weather forecasts, that are going to have an impact, be it on reservoir levels, on humidity, on temperature levels, on the switch yards of station, and so on. These are some success stories. This is a power plant that has 16 units distributed on 5 power plants, but they're all under the same system. They're all monitored. They are operated from 300 kilometers away from the power plant on this office headquarters, and they are reaping. they're sowing the fruits of having this digital transformation on their systems. Operation costs went down. Availability of the units went up because they were able to run these preventive maintenances before the unit broke down, just like you were explaining before. This is a SCADA system for a substation, a 300 megawatt substation. Pretty much over the same idea, having all the information presented in a very user-friendly way to take better decisions, to minimize mistakes from the operators. This is a 45 megawatt power plant of 2 Kaplan units. The same thing, a little older graphics, but trendings, easier information to interpret for the day-to-day. Sorry. And on top levels, this is a transmission line that covers all of Central America. These are 1,800 kilometers of transmission line on 230 kV. Over 4,600 transmission towers, 50 substations, 60 air base, and they are all monitored on this dashboard in order to see the tendencies on the power flow between country substations. And just a little extra, we also work with reservoirs, descenders, trash tracks, water conduits, open channel, closed loop cooling systems, transmission lines, ADMS systems, solar monitoring, and just a little of where else we are. This is an example of a trash track. So the civil work, it's on the picture, and then its representation on the SCADA system it's very similar. So the operator knows what he's doing, can put a face on it, so to speak. And then the control system, there's always a local system and the screen. Done. This is another substation, and okay. Yeah. Let me just power through. Up. Wind. This is for a wind plant.
Thank you, Mr. Gonzalez. So you can come in here. So, Mr. Gonzalez consumed almost like 15 minutes. Thank you for a wonderful presentation. We were listening. It was a really nice presentation, but we'll ask question at the end since you already consumed like whole 15 minutes. Meantime, I'd like to request our team to play the LIDAR technology video. It's also at another like surveying technology, newest one. Can you play that, please?
Introduction to LIDAR. LIDAR, or light detection and ranging, is a transformative technology that utilizes laser pulses to measure distances and create detailed maps of the Earth's surface. By emitting laser beams and analyzing their reflections, LIDAR systems provide accurate distance measurements, making them invaluable for mapping terrain features such as mountains and valleys. This technology's ability to generate precise 3D representations of landscapes enhances its utility across various industries, including agriculture, forestry, mining, urban planning, transportation, and notably, hydropower surveying. Advantages of LiDAR in hydropower. 1. High resolution and accuracy. LiDAR systems provide exceptional precision, enabling detailed terrain analysis and hydrological modeling. 2. Rapid data collection. LiDAR's efficiency allows for swift coverage of large areas, making it ideal for time-sensitive projects like flood monitoring. 3. Vegetation penetration. LiDAR can penetrate dense vegetation, providing accurate ground elevation data crucial for assessing environmental impacts and optimizing project designs. Challenges, limitations, and solutions of LiDAR. 1. Cost considerations. Initial investments in LiDAR equipment and data processing software can be significant. Strategic planning is necessary to ensure cost effectiveness. 2. Accuracy limitations. Factors such as system specifications and environmental conditions can affect LiDAR data accuracy. Employing complementary surveying techniques can enhance accuracy. Comparison with traditional survey methods. LiDAR surpasses traditional survey methods in accuracy, efficiency, and cost effectiveness. Its ability to penetrate vegetation addresses limitations of methods like total station survey and drone survey, providing comprehensive data for analysis. Conducting hydropower surveys using LiDAR. 1. Plan your survey. Define survey area and determine the required level of detail. 2. Select the appropriate lidar system. Choose the type of LiDAR system based on project requirements. 3. Data collection. Plan flight parameters and use airborne LiDAR systems to collect point cloud data. 4. Ground control points. GCPs established using the GPS to enhance data accuracy. 5. Data processing and quality control. Filter and classify point cloud data to generate DEMS, DSMs, and orthophotos. 6. Integration with authoritative combination data with other geospatial datasets for comprehensive analysis. 7. Hydrological analysis. Utilize them for terrain modeling and flood modeling. 8. Project design and decision making. Use LiDAR data for hydropower plant design, transmission line planning, and environmental impact assessment. Conclusion. LiDAR technology is integral to Nepal's hydropower sector, offering capabilities in data acquisition, analysis, and project planning. Continued investment and integration of LiDAR into hydropower projects are essential for achieving energy security and environmental sustainability in Nepal. Acknowledgements from IPN.
Thank you. Thank you for being patient in spite of such a purely technical session. Thank you so much, audience. Now, I'll move to the next presentation. So that's yet to be happening in Nepal. So role of carbon credit in climate change mitigation through the modern technology. So I would like to request Mr. Denzil Swami, Manager Business Development, AK Energy Service Limited, India, to present their presentation, please. So you will have 10 minutes.
Yeah,
so
sure.
we'll remind you in 9 minutes. Thank you.
Good afternoon, everyone, and namaste to everyone. My name is Denzil, and before starting a presentation, I would like to show a short video of our company. If you can, anyone. this was our short video of our companies. Now I will just quickly introduce about our company. Our company name is EK Energy Services Limited, having headquarter in Indore, Madhya Pradesh. We have our offices in Turkey, Vietnam, Ghana, South Africa countries, and recently we have launched our IPO in Bombay Stock Exchange. So we are the only company who has been listed in environmental sector in Bombay Stock Exchange in April 2021. We have also had a joint venture with Shell, in which we are developing nature-based solution, forestry projects, and claiming carbon credits out of it. We have our own manufacturing unit in cook stove. We manufacture cook stove and deploy this cook stove to the beneficiary who has a requirement of this cook stove, and we replace this cook stove with a traditional way of cooking, like you can say clean cooking. So these are all our services. Apart from this, we also provide sustainability services, in which we ask clients to get connected and having their carbon footprint measured and get offsetted using SBTi and other mechanism that is currently going, right? And we are 15 plus old company, having projects all over the globe, like 40 plus countries we are working with. We have 3,500 plus clients, around 1,000 plus projects in every sector, not only in renewable, but also carbon avoidance like cook stove, NBS projects, and different energy efficiency projects also. We have already traded 200 plus million credits to our buyer, and we are known as a leader of global carbon market. We have acquired 90% of share in Indian carbon market, and we are amongst top 5 in the world. We have India's largest carbon asset management firm also. So this is a brief history about EKI. These are the services that we provide in India as well as across the globe. Carbon credit and climate change services, climate investment in ICS, improve cook stove and LED, nature-based solution. As I told you that we help to develop forestry projects, sustainability and ESG, and renewable energy attribute, which is IREC, which will be soon be introduced in Nepal also, and many of the projects like solar, wind and hydro would be soon be registered under IREC mechanism, which is International Renewable Energy Certificate from Netherlands. So this is a basic introduction about carbon credits. What is carbon credit? So if you reduce 1 ton of CO2 or any 7 GHG gases equivalent, you are eligible to claim carbon credit out of it. So for example, if you are having 1 megawatt or 10 megawatt of hydro plant, which is eligible to claim carbon credits, we developed this project under carbon credit mechanism and helps to register it, verified, and you get the issuance done. We also help client to get it mitigated, or you can say monetize, through selling this carbon credits to a available buyer. So this carbon credit is transferable unit instrument, you can say, in which anyone who wants to offset 1 ton of CO2, they can purchase carbon credit directly from that project or from EKI directly. So this is how carbon offset trading works. EKI, Site A, carbon emission company, who has a requirement of carbon credits, acquired carbon credits from a developing country or least developing country who has been rich in renewable energies sectors like wind, solar, hydro, or any energy efficiency project. So EKI helps to develop this project and issued carbon credit on behalf of the project owner. These carbon credits are then be traded to the emission country, like developed countries, who has this obligation to purchase carbon credits. So we help company to register and transfer this carbon credit to the end user. So these are the source of carbon credits from where you can earn carbon credits. So first is renewable sector, of course, in which all kind of projects like wind, hydro, solar power plants, biogas, biomass, solar hydro pumps, every renewable sector comes under renewable energies. Apart from this, there is energy efficiency projects, in which we develop project in fuel switching and improved cook stove projects comes under these projects. Apart from this, household community, you have seen in this video also have there is energy efficiency improved cook stove which we manufacture and deployed those cook stoves. So this kind of project is also registered, which helps to reduce carbon dioxide from the market from the project. And this kind of cook stove credits are very high in price, so we develop such kind of projects also. Apart from this, we have
1 minute.
yeah, waste disposal, scrap metal, and waste recycling projects, blue carbon, forestry projects, transport, and plastic recycling is a newly launched project. You can say if you are recycling plastic, then you are eligible to claim plastic credit even. So these are the projects, waste management projects like compost, biomass projects, legacy waste projects, plastic projects, biofuel, waste to electricity project, biochar, which are newly launched, or you can say verified methodology currently in the VCS. That project also can be eligible to register under VCS, which is Vera mechanism. So these are the carbon credit standard in which we need to register the project and claim carbon credit out of it. So CDM is the oldest mechanism out of all. Gold standard, VCS, Puro Earth, Sir Carbono, and GCC. These are the few well-known mechanism that is currently in the market, which helps to issue carbon credits. And EKI has been a pioneer in this sector and have developed around 1,000 plus projects under VCS, Sir Carbono, and GCC jointly. So these are the carbon credits process, how the project is eligible and how to know the project eligibility criteria. Like pre-feasibility analysis will be done once the project documents has been available to us. Project design has been helped by EKI. Validation, registration, monitoring, verification, and issuance will be done by EKI, in which only project owner need to help with the documentation process. Rest all the development of the project will be done by EKI itself. So these are our corporate clients, which includes Greenco Group, Adani Group, Renew Power, SB Energy. We have been working with all of them and have developed their project under carbon credits market. And these are our governments. We are also working with Indian governments like Indian Railway, Indian Oil Corporation, Bharat Petroleum, Hindustan Petroleum, Uttarakhand Power Corporation, Kerala State Electricity Boards. So this is all from my side. If you have any question regarding this, you can ask me.
Please come. Yeah.
Thank you so much.
Thank you, Mr. Swami. So we'll take 2 questions. Please introduce yourself and brief one. Only a question, please. So anyone? Any question? Yeah. Can you give mic there, please?
I am Bhat Sundar Malla, electrical engineers. And my question to Mr. Swami, that first part he has very well covered about his company. And the next part, is any project in Nepal you have carbon credited for Nepal? Number 1. And number 2, how the transport project is included in the carbon credit? Thank you.
Thank you. Thank you so much for asking this question. Yes, we have